All right, this is a very brief video on activity 1.3.4, which is more CAD design skills. We're going to look at patterns, lofts, tapered extrusions, offset planes, and shelling are going to be our new skills that we're adding into our CAD skills. So you will have 5 screenshots that you're going to submit for this particular activity, and I'll get into those on the next slide. So deliverables, multiple screenshots. For activity 1, we're going to do a colonial flag. The goal of that particular activity is to do the circular pattern. So the thing that I'm going to be looking for when I grade that mostly is going to be, did you get the circular pattern down for the stars? If there are just some weird things that happen with this particular design. So I think, if there's other things that are messed up about it, if you get like 4 out of the 5 points because your stripes get a little crooked or something, don't sweat the small stuff. Try to get it right. But the goal of that is the circular pattern. For activity 2, we're going to be doing a screw holder, and you're going to do 3 screenshots to demonstrate that you have successfully done the screw holder. One of them will be the isometric. One will be a section view. So you're going to take that plane and slice it into your screw holder. And then one will be from the bottom showing that you shelled the screw holder. And then your last is going to be some automata work. So pick another topper for your automata, go back into your concept sketches, go back into your brainstorming, something that you might use for your automata. If you're like, well, I don't know about the topper, but I have this other idea, let me know. It needs to be something for your automata. And I want you to design that using at least 2 of the skills that we covered. You don't have to use all of them, but either use a pattern, use a tapered extrude, use a loft, use an offset plane somewhere in your design process. And then each of those screenshots is going to be worth 5 points for a total of 25 points in this particular activity. Now, this obviously isn't a colonial flag. Last year when I put this up there, kids were like, that's not a colonial flag. Thank you. I know. So what we want this for, though, is for the correct proportion. So in order to get the dimensions right, we need to know the proportions. Again, the point of this particular design is to practice the patterning. So I'm not really concerned about what specific units you use or how you scale this. You can actually find all sorts of calculators online for that. I didn't know that. So we're going to make the hoist of the entire flag. That's A. We're just going to call that 1. The fly is going to be 1.9. The hoist of the union will be 7/13. And the fly of the union would be 0.76. And then, of course, we'll do the 13 stars arranged in a circular pattern instead of what they have there. So you can use millimeters, inches, feet, miles. It doesn't matter because the skill that we're practicing is the pattern. And again, we just want to get the proportions right on this. So we're not winging it with the proportions. So this is one that I did last year. This was my first attempt. And before I assigned this to my students to do, I wanted to try to do it myself to see if I could make it work. So I ended up with 14 stripes and one line that clearly went off course. There it is. And I'm not even sure how that happened. Like I wasn't able to put the right constraints on that to pattern that the way that I wanted it patterned. And I wrote, hopefully my video will be smoother and the in-class demo even better, because like with all things in life, sometimes you just need to get some practice. And of course, at the time I'm recording this, it's been several months since I've tried to do it. So just remember that the goal is to learn how to practice linear and circular patterns, or rectangular. We're just going to do rectangular, but we're going to do in one direction, which will make it a linear pattern. And so if other things start to run a little bit amok, again, don't sweat the small stuff. It's a 25-point activity. If there's something non-essential to the point of the activity that isn't quite right, I don't want you to fall way, 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 way behind because you're trying to fix a stripe and then you don't get to the screw holder at all. At some point, you just have to say, okay, I got the point of this. I can do the circular pattern. I will submit it, move on to the next thing. Okay. And I know that's really hard for some of you to do, but try. The second activity is the screw holder. And this is a cat that just jumped onto my lap. So this is what you're going to be designing, and I'll read through what the steps are on this. So this lesson included a lot of measurement and angle estimates. If you look at what it is in the PLTW curriculum, they have tons of measurements for this. And it just, some of them, I didn't think they had all the measurements there. Um, and pretty much we want to practice the skills. So we're just going to not focus on how big the things are, like how much do I have to extrude it? Don't worry about how much you have to extrude it. Just make sure that you get the extrusion done. So here are the steps. You're going to draw a pentagon. So we haven't really done drawing polygons yet in CAD. We will obviously cover that when we do this in class. We'll do the polygon. Extrude it with a tapered extrusion. Now, this is an angle of -45 degrees. This is the direction that I did it because we want it to taper inward. I'll have to check in Onshape what the angle needs to be. If you put in the -45 and it's going like out, then make it +45, and that might change depending on the orientation that you have. Then extrude it again with a taper angle of about -2 degrees. So if you can see where I'm pointing, you're going to draw the pentagon. You're going to extrude it with this like 45-degree angle, and then you still have the pentagon and you're still extruding it, but you're extruding it at a different angle. And so it actually looks like two different shapes almost, but it's not. It's the same shape, just being extruded at different angles. Then you're going to create something called an offset plane, which is what it sounds like. It is a plane that you're going to offset from the top of your pentagon. We're going to draw a circle on the offset plane and center that circle on the center of the pentagon. And you can see mine clearly was not centered. Wasn't centered, and I didn't want to go back and fix it afterwards. This isn't the particular point of this part. So as with a lot of these designs, we want to keep the main thing, and remember what it is that we're trying to learn. And in this, we're trying to learn how to do a loft between the pentagon and the circle. The goal isn't make sure the circle is in exactly the right spot. So just kind of keep that in mind. It's okay if it's a little bit off, like just what we're trying to do here. So we're going to create a loft. That is this piece of it right here. It's where a loft is where you connect two different shapes, usually two different shapes. I guess it doesn't have to be though. And you try to get this like nice smooth connection between them. So it's that part right in there. Then extrude the circle upward. And again, notice there's no measurements on this. You're just going to extrude the circle upward at an angle of -2 degrees. So we're working on those tapered extrusions. Fillet the top edge, which is that edge right there. So just kind of seeing that top edge down. Extrude a hole in the center that goes almost all the way to the bottom. So when I flip it over, there's the hole that goes almost all the way to the bottom, that center hole. And then use a circular pattern to create 5 more holes. And those are going to just go part way down. Those hold the screws in there. So those are the 5 holes. And notice that they do not go as far down as that center hole does. And then shell the part. That's what enables you to see what's going on the inside. It also saves you a lot of material. So if you don't need to, especially like we're 3D printing or something, you don't need to have a solid object. You can go ahead and shell it and it will print things much faster. It'll give us a much more efficient print job. So that's the steps. Again, there's very few measurements in here, just the particular angles on the extrusion for the tapered extrude. And I will do a demo video of these inside of the CAD programs. Hopefully I'll do better than my first attempt at it, which was a few minutes ago. And then let me know if you have questions about what you need to submit.